wondering what a hyperbola looks like? Well, here it is. It basically looks like two mirrored parabolas. A careful definition of hyperbola is a symmetric curve formed when the cutting plane intersects with two equal cones on opposite sides of the vertex. The sum of the difference between the foci and the point are constant. The graph will become a hyperbola when the cutting plane angle is lesser than the generator angle. So basically, if two cones are positioned like this, a hyperbola can be formed if the cutting plane angle cuts here.
There are two equations of this conic section in standard form. This equation is used when the transverse axis is horizontal, which looks like this. The center, foci, and vertices will line up parallel to the x-axis. This other equation is used when the transverse axis is vertical, or in other words, when the center, foci, and vertices line up on top of each other parallel to the y-axis. And this is what the standard equation of a hyperbola looks like.
H is the x value of the center point, k is the y value of the center point, x is the y value of the horizontal transverse axis, and y is the x value of the vertical transverse axis. A is the distance between the center and each vertex, and lastly, b is the height of the fundamental block. If you're wondering what the fundamental block is, keep watching.
As you can see from the standard form, the results will always equal to 1. If the other side of the equation does not equal to 1, it means that the hyperbola is in degenerate form, which looks like two intersecting lines.
Now, if you know that the center is at the origin, or the coordinates 0, 0, then you can use this simpler version of the standard equation. If you look closely, you'll see that it's still the same equation. However, because the h and k values are 0, we can eliminate those variables from the equation. Since we know that the vertex is a distance away from the center and the focus is c distance away from the center, we can easily find out the coordinates of the point through an equation. If you know what the Pythagorean theorem is, you'll find this equation familiar. C squared equals a squared plus b squared. So basically, we can plug in the known variables to solve for a, b, or c, and use those distances to find where the point is.
In a situation where the equation is presented as a general form and not in the standard form, there's an easy trick to how you can identify whether the equation represents a hyperbola or not. A multiplied by c have to be less than 0.
Now, enough of the boring information. Let's see what interesting properties hyperbola has. You will be surprised, but hyperbola is the only conic section that has asymptotes. As we zoom out, the hyperbola will start to look like two lines. These are the asymptotes. Every hyperbola has two asymptotes. When we rotate it along the vertical axis, one will be on top and one will be on the bottom. When we eliminate the one on top, we will get hyperbolic funnels. This explains the gravitational energy around the sun according to Newton's law of gravity.
After hearing us lecture, you are probably wondering, when will we even use this kind of equations and formulas in real life? Well, I'm letting you know that hyperbolas can be found in our everyday life. Exciting, right? For example, hyperbolas can be found in lamps, running tracks, or even hourglasses. Okay, maybe that's enough.
And now, Tangmo will be showing you how we can easily solve hyperbola conics problems.
Hi guys, I'm gonna start with the formula we need for today. And it is the standard formula of the hyperbola graph, the c, and the asymptote. So this is the standard form of the hyperbola graph. And next will be how we solve for c, which is c squared equal a squared plus b squared. And the formula for the asymptote is y minus y1 equal m bracket x minus x1. Some of you might wonder why do we have two standard formula. It's because if y is come first, the graph will be horizontal, but if x come first, then the graph will be vertical. And this is like a trick. Okay, let's move on and work on our problems for today. Okay, so the problem is y minus 1 squared over 9 equal x minus 2 squared over 16 equal 1. So we start off with identifying the h and the k. So 1 is the k and 2 is the h. And now we find the center point, which is h and k. But then you have to make sure that every time h and k from the equation will be switched the sign. So in this case, the center point will be 2 and 1. So varieties are a, b, and c. 9 is a square and 16 is b square. So a square equals 9 and a equals 3. B square equals 16 and b equals 9. And from the c formula, we could find that the c turned out to be 5. So now we got a, b, and c. And then we make the graph. Once you finish with the coordinates, you just put the center point, which is 2 and 1. And then you can look at the A number, which indicate up. We go up, down, left, and right. So we go up 3, make a dot, go right 3, make a dot, left 3, make a dot, and down 3 to make a dot. Then we simply connect the dot into a square or rectangle. And then this helps us identify the asymptote by drawing a slant line from the center point to each end of the square. Then we put a big dot at the vertex of the two parabola graph. Then we simply draw the two parabola graph or the hyperbola graph. And now we got all the information we need, except if you want the formula of the asymptote, you can work on with the formula we already have or already given. Based on the formula, what we need is the slope, and we can find it on the graph. So in this case, it's up 3, right 4, and up 3, left 4. And from this formula, y subtract y1 equal m bracket x subtract x1. The first equation we're going to solve is for the positive linear line of the asymptote. And the slope is 3 over 4. And for the other one, the m value will equal to negative 3 over 4. And that's all. Yay!